Can turbulent flow occur far away from any boundary?
Oh no. I left my fluids textbook at home. What am I going to do?
This sounds like a job for Fluids Man. What seems to be the problem, friend?
Well, I've been having trouble with this question right here.
Looks like we'll need the whiteboard of science.
To answer this question, let's take a look at fluid far from a boundary. Near a solid object, we have seen that a boundary layer forms. Far from the boundary, the flow is uniform. Near the boundary, viscous forces dominate, but far away, we can assume that the fluid is inviscid, meaning that viscous forces are negligible. Now, let's consider something called the Kelvin circulation theorem. The theorem basically says that the line integral of the fluid velocity around a closed curve of distinct fluid particles is a constant. However, the theorem requires a few key assumptions to be true. Body forces must be conservative, like gravity, density and viscosity must be constant, and the fluid must be inviscid, which we now know it is when far from a boundary. So let's look at an example of the Kelvin circulation theorem. Here we have 5 fluid particles in a laminar flow. In reality, you would take the integral over many particles, but we're using 5 for simplicity. To calculate the circulation, we take the line integral of the velocity around the 5 particles. Now, let's look at the particles sometime later. Because the flow is laminar, they have all moved in similar ways. We can once again find the circulation by taking the line integral of the velocity around the particles, and the value we find will be the same as before. So how does this relate to turbulence?
Here, we can see laminar flow. The flow is smooth, steady, and predictable. Whereas turbulent flow, it's unpredictable, it's unsteady, and it's chaotic. So that brings us to turbulence.
So now, let's try to apply the Kelvin circulation theorem to a turbulent flow. Here, the particles are moving chaotically. Let's calculate the circulation in this first position. When we look sometime later, the particles have moved into random new positions with random new velocities. To calculate the new circulation, we must evaluate the line integral of the velocity around the particles in the same order as before. If we do this, we will get a different value for the circulation. We see here that the Kelvin circulation theorem does not hold for turbulent flows. But wait! We found earlier that, far from a boundary, the Kelvin circulation theorem does hold. This can only mean one thing. Flow far away from a boundary is laminar and not turbulent.
Does that answer your question?
Oh yes, it absolutely does. Thank you very much, Mr. Fluids Man.
Looks like my work here is done. Fluids Man, away!
What is going on here? You're not allowed to receive outside help on an exam. That's a violation of the Cornell Code of Academic Integrity.